Hello friends, this video sequence and series part 20 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched videos part 1 to part 19. This equation we are told that ABC are in GP and a to the power 1 by x is equal to b to the power 1 by y is equal to c to the power 1 by z is equal to constant. So we have to prove that x, y, z are in AP. So we say that a to the power 1 by x is equal to b to the power 1 by y is equal to c to the power 1 by z is equal to say constant, some constant. So from this equation, so first equation is a to the power 1 by x is equal to k. We'll multiply this equation to the power x to the power x. So we'll say a is equal to k to the power x. Similarly, b to the power 1 by y is equal to k. We'll also raise this thing to the power of y, so we get b is equal to k to the power of y. Similarly, c to the power 1 by z, will raise this to the power z, this become k to the power z, or we get c is equal to k to the power z. So we have a, b and c, k to the power x, k to the power y, k to the power z. Now we are told that a, b, c are in GP, that is b square is equal to ac. So b square is nothing but k to the power 2y and AC is k to the power x into k to the power y. So this becomes odd k to the power 2y is equal to k to the power x plus y. If you take from this equation we can say 2y is equal to x plus y, x plus z, sorry, this is z, x plus z, or y is equal to x plus z by 2. Thus we prove that if y is equal to x plus z by 2, that means x, y and z are in AB. So we have proved this. Very simple. What we have done, we were told that a to the power 1 by x is equal to b to the power 1 by y is equal to c to the power 1 by z. We have taken this as constant. We found the value of a, b and c. A is equal to k to the power x, b is equal to k to the power y and c is equal to k to the power z. Since a, b, c are in GP, we have used this formula b square is equal to ac. We have solved this and we got that y is equal to x plus z by 2, which proves that x, y, z are in AP. So we are told that a, b, c, d and p are different real numbers such that this a square plus b square plus c square into p square minus 2ab plus bc plus cd into p plus b square plus c square plus d square is less than 0. We have to prove that less than equal to 0, equal to is mandatory here. We have to prove that a, b, c, d are in GP. So what we observe from this equation, let me write this equation first. A square plus b square plus c square. Okay, let me expand this, or let me expand this. A square p square plus b square p square plus c square p square minus 2abp minus 2bcp minus 2cdp plus b square plus c square plus d square, this is less than equal to 0. Now if we see that if you take a square p square, correct, and if you take apb and here b square, this is nothing but ap plus b whole square, because ap plus b whole square, you get this is a square p square plus b square minus 2ap b. That's what we have seen if you take this and this, correct. So let me factor this. This becomes a square p square minus 2abp plus b square. I'll put this in one bucket. In the second bucket I'll say b square p square. So I'm taking b square p square. So if we have this bpc, so I'll take c square here, b square minus 2 bcp plus c. This is second bucket. Second bucket I'll write here like this. Now I'll take third bucket. So cp, and this is cpd, and this is d square. So I'll take this bucket. This becomes c square p square minus 2c dp plus d square. This is third bucket. I'll make it circle here. Circle, circle, circle. This whole thing is less than 0. So I made these three bucket. So this is nothing but AP minus B square. This is nothing but BP minus C square. And this is nothing but CP minus D square. This is less than or equal to 0. Since we have squares of number, it can't be less than 0, because 3 square plus 4 square can't be 0. At the max it can be 0. The maximum, the minimum positive number, the minimum number it can have 0. So we'll see that means all are 0. That means this is also equal to 0, this is also equal to 0, and this is also equal to 0. That's what we have got. So we say AP is equal to B, or we say P is equal to BY. Similarly, BP minus C is equal to 0, or we say P is equal to, we get this C by B. This is plus C by B, or this is equal to, actually here also we get CP, this is CP minus D, CP minus D is equal to 0, or this is all P is equal to D by C. So we have got P is equal to, so we have got P is equal to B by A is equal to C by B is equal to D by C. Thus we can see that this is a GP, because we have a term A, B, C, D. B by A is equal to C by B is equal to D by C. That means this is a GP. Very simple what we have done. We knew that we can convert this form in A plus B or A minus B square, and we know that if you square a number, the minimum positive value can have 0. So we fitted all this thing to 0, and we got the answer. In this equation we are told that P, Q are in GP. So I'll write that P, Q are in GP. P, Q are in GP. And also the equation Px square plus 2x plus r, that is this equation, and this equation have a common root. So let's first find the root of this equation. Px square plus 2qx plus r. So root of this equation, if you say x is equal to minus b, that is minus 2q, plus minus root b square, that is 4q square, minus 4ac, 4pr, ac by 2p by 2. Now since p, q are in GP, q square is equal to pr, so we can also say this is minus 2q. This becomes 0 because 4q square is equal to 4pr. This becomes 0. This is minus 2q by minus 2p. That is minus q by. So this is the value of x in this equation. Now since this equation and dx square plus 2ex plus f, this equation both have common root, so I can also put x is equal to minus q by p in this equation. That will be a valid. So dx square plus 2ex plus f is equal to 0. We can also write this equation as d into minus q by p square plus 2 into e into minus q by p plus f is equal to 0. I can do this. This we can say as d q square by p plus f is equal to 2 into, that is 2e q by, this is we can say. Now we have to prove that d by p, e by q, f by r and ap, that is d by p plus f by r is equal to 2e by p, 2e by q. This is we have to prove. Until now we have got this. Somehow we have to convert this into this. So we see d by p we have got q square is extra here, and here we got q. So what we can do, this is p square actually. We'll divide this equation by, because you want d by p here, right? So we'll divide this equation by, to get d by p, q square. If you divide this by q square, this is gone, q square by p. If you divide this equation by q square by p, this becomes d by p. So we'll do that. So this becomes d q square by p into p. This is what we got, dq square p square. We'll divide this by q square p. Also we have to divide the whole thing by q square p is equal to 2eq p. Here we get q square p. Why have we done this? Because we wanted to make this in d by q form. So q square p, q square is cancelled here. Here also p is cancelled. Q square, q is cancelled. So what we get here is d by p plus f p by q square. F p by q square is equal to 2e by q. So we have got this. We know q square is equal to p r because p, q, r and gp, and we wanted to put this because we wanted something in f by r form. So we can also say d by p plus f p by q square is equal to pr is equal to 2e by q. Here p cancel, or what we get is d by p plus f by r is equal to 2e by q. And that is our answer. Very simple. What we have done, we have found the value of x in this equation that came out to be minus q by p, and we knew that both this equation have a common root. That was the only root of this first equation, so we have used this equation root in this equation, solved it, and since we wanted to find this, so we divided this equation by p by q square because we wanted to get d by p form, and then we got this here also we wanted to get f by r form, so q square we wrote as p into r because p, q, r and gp, and to get this answer. The only thing is you solve this equation and then you first note down what you want to prove. So here we wanted to prove this, and then we mold our equation based on our requirement. We divide or multiply this equation with some constant, or we add this number with some constant. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.